Our goal is to find the inverse of this function, which happens to have a trig function in it. The good news is the process for going about this is going to be the same as the process you've probably used for finding inverse functions in the past. The first thing we're going to do is swap x and y. So everywhere there's an x, I'm going to put a y instead. Everywhere there's a y, I'm going to put an x instead. And now the goal is to solve this for y. I'm going to have y equals, and that'll be my inverse function. Well, let's see. First thing we're going to do is I'm going to add this 2 on both sides. And here's my y. It's in here behind the cosine function, inside the cosine function. I need to get it out, and the way I'm going to do that is by using the inverse of the cosine function, which we have one. That'll be the inverse cosine function. We're assuming in here that y is such that domain and range isn't going to be an issue and that it makes sense to do an inverse cosine. So just to show everything that's going on here, I'm finding an inverse cosine of what was there. If I'm going to do an inverse and the original function composed with each other, I should end up with just what I started with, which here is 3y. If I do an inverse cosine on the right, I had better do the same on the left. And last thing left to do to solve for y, I'm going to divide by 3. You can just put divided by 3 if you want. I like multiplying by 1/3 instead of divided by 3. I think it just looks a little cleaner, but it doesn't matter. So 1/3 inverse cosine of x plus 2. And there's my inverse function.